So today we're going to continue studying subtracting integers. I'm going to show you something a little bit different than we did yesterday with the chips. The chips are amazing if that's what you use in your head. Even if you have them and you physically move them out, that's perfect. But they can become a little cumbersome because of how many you have to have. So there's another way that we're going to talk about today that you won't require chips for. Before we get into that, I want to take a flashback to addition because you're going to find that these two are related. And I have this handy graphic organizer. I will post this in Google Classroom as we go and then when we're completed. If you want to take a screenshot of it right now or remember where it is in the video and come back so that you can use this while you're doing your problems, that would be helpful for you. So we start with addition, and there's basically two things that you need to look at when you're doing addition of integers. Do my numbers have the same signs? Or do my numbers have different signs? And I gave an example for each. So if they have the same sign, for example, -3 plus -2, all you're going to do is add them up and keep the sign. In this problem, it would be a pile of 3 reds and a pile of 2 reds, and you smush them together, that's the adding, and you get a pile of 5 reds. And because they're red, we say it's negative. All right, so when they're the same, regardless of both positive or both negative, you simply add them and keep the sign. When you've got different signs for addition, you end up subtracting. I know it's crazy, but roll with me. You remember doing this? So we would put up a pile of 9 reds, and then we would put up a pile of 5 black, and we would smush them together, and we would get some not pure color. They would be all mixed together. And so I would have to start taking out those 0 pairs. Remember 1 red and 1 black? That's the subtraction part. Whatever was left over was my answer. We shorten that to say you keep the sign of the bigger pile. In this example, the 9 was the bigger pile. I don't care what color it is, 9 is still a bigger pile than 5. So whatever sign the bigger pile had, whatever color that was, that's what's going to be left over. So when I was done taking away those pairs, I had 4 reds remaining, which means my answer is -4. Now, I'm going to show you in just a moment, when we get to subtraction, you're actually going to turn it into an addition problem. And then we go back and use those same rules. All right? There are models, there are number line, there's all kinds of things that I could show you. Trust me, you're going to like this. You're going to want to change it to an addition problem with some rules. It doesn't just magically happen. You're going to use something called the additive inverse, or a shortcut reminder I call two-stroke. And then you're going to follow the addition rules. So a real quick example before I show you how to do it for real. The problem originally was 7 minus -4. Now, I'm not a big fan of subtraction, so I changed it to addition. But in order to do that, I can't just make 1. I have to make 2 strokes. That's why we call it two-stroke. 2 strokes with my pencil, change this to addition, and change the sign after it. So my new problem, that I'm going to explain more about in just a minute, has become 7 plus 4. And you've been doing that problem for a long time. You know that the answer is 11. Okay? We'll talk about that in a minute. Some other words, remember, absolute value, the distance from 0. The opposite, the number that is the same distance, but on the other side of 0. So for example, 7 and -7 are opposites. And then our friend, the 0 pair, which we used up here when we were taking things away. All right, so I'll let you take a screenshot of that if you need it, or pause the video so that you have it available to you. Okay, let's get into some examples for subtracting integers. Now, every subtraction problem that you have ever done has been, well, I can't say that. Most of the problems that you've done have been subtracting integers. When you talk about elementary school problems like 5 minus 3, those are integers. They just both happen to be positive. Okay, so let's look at one that's going to cause you a little bit more thought. 6 minus 7. It is not 1. This is like saying I have $6 and I have to take $7 out of my account. Well, how are you going to do that? You don't have $7 to take out of there. Now, with numbers like this, you could probably figure out that the answer is -1. But let's use this new method. Okay, we're going to do something called two-stroke, or use the additive inverse. I'm not a fan of subtraction. You'll hear me say that when we go through this. So I'm going to change this to an addition problem. But if I only make that one pink line, I've changed the problem, and that's not going to work. So in order to keep this exactly as it was, I make 1 mark, 2 marks. I change the sign of the number that comes after it, the last number. So now this says 6 plus -7. It's the same thing. And then I can go back to my addition rules and say, well, they have different signs, so I'll subtract. 7 minus 6 is 1. Which pile was bigger? This one. So my answer is -1. Now, if you think about your bank accounts, you have $6 in your account or $6 in your wallet, and you need to give somebody 7. You don't have enough. So you're going to give them all that you have, and you'll still owe them $1. Let's look at another one. The problem is -10 minus +7. And students often say, well, is that a subtraction sign or is that a negative sign? And I kind of smart alecky say, yes, it's actually both. The way that you would read this is -10 minus 7. But the way you're going to think about it when you go to calculate is that this is a -10 and this is a -7, and we're smushing them together. It's a little bit of a different way to think about it. Okay, so let's do our 2-stroke. I don't like subtraction, so I'll change it to addition. And by changing it to addition, I must also do a second one and change that to a negative sign after it. So step 1, let's try to spell steps right. Step 1, we're going to change subtraction to addition, and then immediately change the sign of the number to the right, or the number that comes after it. All right, so I've done that. Now I need to go through and calculate. Back to my addition rules. Do I have the same sign or do I have different signs? I have the same. This is a negative and this is now a negative. So when I have 2 of the same, I just push them together and keep the sign. So what's 10 plus 7? 17. We'll keep the sign. And there we go. Now, let's think about this in terms, I'm going to rewrite the original for a second. Let's think about this in terms of temperature. Negatives are cold. Positives are warm or heat. If I have cold and I take away heat, what happens? What happens when I take away heat? It gets colder. Well, isn't -17 colder or lower than I started with? Yep. All right, 2 more of this style. 1 minus -2. Sometimes you'll see the parentheses to highlight that that's a negative. Sometimes you won't. It doesn't make a difference. I'm not a fan of subtraction, so I'm going to change it. But if I change one, I need to change the other. Immediately, you got to make 2 marks because they will cancel each other out. And now this has the same value as it did originally. It's just a little easier to solve. So I've changed the problem into 1 plus 2. Yeah, I could put that second positive in there, but I'm not going to. Well, you know 1 plus 2. You've been doing that for a long time. They have the same sign. So by my addition rules, I'll add and keep the sign. Let's go back to temperature. If I have heat, I know 1 is cold, but work with me here. It's positive. If I have heat and I take away cold, I remove a negative. What happens when you take away cold? It gets warmer. So is this higher than we started with? Yep. 1 more. Negatives all over the place in this one. -15 minus -5. So I don't like the subtraction. I want to change it. If I change this to addition, I must immediately change the number that comes after it. I'm actually going to get rid of these parentheses. So I've changed my problem into -15 plus 5. I didn't really change it. The value is still the same. It's just a little easier to calculate. Okay, so let's go to our addition rules. Do I have the same signs or different signs? They're different. So what do I do when they're different? I subtract. 15 minus 5 is 10. And my sign is whatever pile is bigger. I don't care whether they're red or black. I care how many there are. 15 is a way bigger pile. So there's my answer. I'll add up here. Follow addition rules. Okay, so if you get one of these subtraction problems and you're not a big fan of it, change it to addition, immediately change the thing after it, change the sign, and then you've created an addition problem and you can follow those. All right, now when you're ready to go to the next level of these, there are ones where you're going to have variables that you have to substitute. You have to be super, super careful with these. All right, so let's say you get a problem that says evaluate the expression m minus n if m is negative 15 and n is 8. I know some of you just said there's way too many letters in that problem. This is math. I get it. These are kind of fun, all right? So evaluate means to solve or to figure out or to test. And here are some of the situations. You know, variables can be anything, but for this example, we're going to say m is negative 15 and n is 8. Another teacher might pick different numbers, but those are what I picked. So what I'm going to do is replace the letters, just the letters, with what I see. All right, so everywhere there's an m, I'm going to replace it with a negative 15. And everywhere there's an n, I'm going to replace it with 8. Everything else about the problem stays exactly as it was originally. So this now says m minus n. All right, so it's a subtraction problem, and I'm not a big fan of subtraction. Let's change it. So I'll change this to addition, immediately change the number after it to the opposite. It was positive, now it's negative. And then I'll use my addition rules. Are they the same or different? They're the same. So I'm going to add 15 plus 8 is 23. And I'll keep the sign since they were both the same color. So my expression, when these conditions apply, equals negative 23. I have one more of those, our last one for this video. Evaluate x minus y if x equals negative 6 and y equals negative 5. Again, we're only replacing the letters. So everywhere there's an x, I say negative 6. And everywhere there's a y, I say negative 5. But this negative goes with this. The subtraction sign still has to come down. That's why I say you have to be super careful with these. So this now says x minus y. Ew, it's subtraction. I don't like subtraction, so I'll change it. Now it's addition, but the thing after it has to be the opposite. So my new problem is negative 6 plus 5. So to the addition rules, do I have the same sign or different signs? These are different, so I'll subtract. 6 minus 5 is 1. And which pile was bigger? This one. Even though they were negatives, the pile is larger than the other pile. So my answer is negative 1. There are lots and lots of little details. All I ask you to do is try it, give it your best effort. You're going to need lots and lots of practice to feel comfortable with it.